I would like to start today's workshop, that is understanding threat modeling methodology with OWASP Juiceshop app. So for today's workshop, myself, Chandan, and Venkat, we both will be talking about this topic. So let me quickly share what is there in today's agenda. First, we'll be giving a small intro about ourselves, and then I'll be talking whether 100% secure products can be possible or not. Then we will try to discuss about a method how we can achieve that 100% security in the applications. And I'll be talking about the Juice Shop app, which we are going to perform the threat modeling activity on that. Once we know what Juice Shop does, then Venkat will be taking us through a session explaining what is threat modeling, how to do a threat modeling activity and all. Then we take Juice Shop as an example, and we'll have a hands-on on threat modeling session on the Juice Shop app. And finally, we will share our result from this threat modeling workshop, and we'll conclude the session. And finally, we will be open for Q&A session. So this is the agenda for today's workshop. Moving on to the first part, introduction. So firstly, I would like to call Mr. Venkat to introduce himself. Over to you, Venkat.
Hi all, this is Venkat here. I'm in software industry since close to 16 years, and most of the time I'm working with SAP, working with a lot of topics like the development in security and authorization related topics. As of now, I am the information security officer for SME solutions, dealing with the security related processes and activities, and also I am dealing with the threat modeling as one of the topics with me. Back to you, Chandan.
Thanks, Venkat. So myself, Chandan, I'm in cybersecurity domain since 2010. Prior to that, I was a developer, and I've come across various roles in the cybersecurity domain, be it pen testing or being in the product security response team. So currently, I'm working as a security product owner for S4 Procure application in SAP Labs, Bangalore. So this is about me. So we shall quickly jump on to the today's topic. So, how many of you think we can develop a product which is 100% secure? Is that even really possible? Okay, so but application vulnerabilities are inevitable. Vulnerabilities exist in all types of software. Maybe several versions of Microsoft Windows OS were open to the WannaCry attack. Also, open source web browser Firefox had more than 100 vulnerabilities identified in its codes each year since 2009. And also, Microsoft Internet Explorer browser had 15 different vulnerabilities every year since start of 2017. So, what is the reason for this? Bugs are guaranteed in software, and a certain portion will be definitely security related bugs. Okay, software development, it's not a perfect process. Programmers often work on timelines set by the management teams. Okay, so they try to set some reasonable goals, but sometimes it can be challenging to meet those deadlines. As a result of this, a developer do their best to design secure products. So majority of the time they give priority to functionality over security requirements. So as they progress, but they may not be able to identify all the flaws before the product release. And also, if they try to delay the product release due to some issues like fixing security requirements and all, it may be costly. So what many companies will do is they will release an initial version of the product, and then when they find these issues, they provide a fix to the customers. So these fixes are called as patches, which cover the security holes. So this is one version why there will be a security vulnerability in the application we ship. And the second thing is day by day, hackers are finding new way to hack the system. We might think that okay, today we have done all the necessary steps to make sure our product is secure, but tomorrow some hackers or some security researcher might find that there might be a new way to hack the existing application. So we cannot predict how one can think and how one can come up with a new innovative way to hack the application. Because of all these reason, we can claim that securing a product 100% is not possible. So this is what we have come to know, that okay, we cannot deliver 100% secure product, but is there a way to make the applications or the product which we ship is as secure as possible? Is there a way to do that? Yes. Let's discuss how we can do that. Okay. So for this, to make sure a product is secure uh, as much as it can be, so security must be considered from the beginning of software development lifecycle. And definitely, this is not a one-time process. It's a iterative process. So we have to go back to the beginning phase again, and we have to identify, are there any security issues possible with the existing design code or the delivery model, and again we have to fix that thing. Okay, so this is iterative process, and it's not only lies between the development team. So everyone should be involved in this, right from the stakeholders to the quality people. So, this is required because every security requirement involves a budget in it, and as a security team, we cannot decide that okay, I want uh, two top level of security might, and this may not be feasible from the stakeholder side. So, all the stakeholders should come to a decision and should decide how much secure the product should be. Okay, and we should also be thinking about the trade-offs. If I am making this application secure enough, what is the impact of that? One example is that to avoid a brute force attack, we might come up with a requirement telling that if a user logs in with three wrong attempt password, that user will be locked. So in that case, even the genuine user can be logged out because someone tries to use that user ID and enters wrong password, and the genuine user may not be able to use the system. So these kind of confusions will be there. So all the stakeholders should meet and decide what should be the final goal of the product, and what all security measure we should consider for this. And also, security and the development team should have a regular meeting to review the architecture or the code or the deliverables, whether it is uh, uh, adhering to the promise what they have made even before the start of the development or the design. Finally, finding a security issue and fixing it in the development phase is way cheaper than fixing the same thing in when the bug is identified in the production, and we have to supply the patch when it is used by the customer. So these are all the things we can do, and there is a process exist for this to achieve this systematically. So that is called as software secure software development lifecycle, or in short form it is called as SSDLC. So let me go through the steps of this secure SDLC. So in secure SDLC, we have four phases. One is preparation phase, the second phase is development phase, and the third phase is transition phase, and the fourth phase is utilization. And in all these four phases, we have multiple sections. If you observe this image carefully, there are a couple of sections which will be overlapped with two phases. So these activities will be done in both the phases. So we have section like training, risk identification, planning security measures, secure development, security testing, security validation, and security response. So we have these many sections in the secure SDLC. Coming to the training, we have topics like security awareness and security programming. What is security awareness? Security awareness is involving everyone who has involved in the development of that software, training them on the security issues. And when I say security training, it doesn't mean that all the all the people who are in different role will get same level of training. A product manager will get training on certain things like security product standards, like that. But an architect or a developer might get training on secure coding techniques. So the security awareness or the security program training program will be different for different roles. And this doesn't exclude quality people also. Even the testing people should know how to perform security testing, and the subsequent training on the testing security testing tool should be given to the quality people also. So in security awareness section, every user who are involved in the software development, they will undergo a training thing. And what is secure programming? Secure programming is a training where the developers and the architects will come to know how securely they can code the application. For example, in case if there is a division scenario, they have to make sure that they will check for a zero in if a zero is passed to the denominator or not, something like that. And in case if the application is taking inputs from the user, probably they have to do the input sanitization before working on that input values in the code. So all these things will be taught in secure programming guidelines training. The next section is risk identification. This is very much required so that they can plan whether how they want to handle that risk. So risk can be handled in four ways. Either they can fix it, they can mitigate it, or they can transfer it, or they can avoid it. So for example, fixing a risk is like um, assume there is a file upload scenario. Fixing that risk is probably adding a virus scanner in the code so that whatever file uploaded will pass through that virus scanner to make sure uh, uh, and not any virus or malware will be entering into the system. Or probably mitigation might be like putting a filter on the size or the file type to make sure only the expected file type or size will be uploaded into the system. Or risk avoidance is like probably if totally taking off that functionality and making sure the application doesn't have the file upload scenario at all. Or risk transfer is like hiring a third party and getting this functionality done through them, and they will take the risk. One generic example is right, taking insurance is a good example for risk transfer. So in case uh, if I have promised my client that I will be doing this service to him, and if I fail to do so, and if I have insured for that service, then the cost will be borne by the insurer. So I am transferring my risk to the insurance office. So these are all the risk handling mechanism. Also, we'll be using threat modeling mechanism to identify the risk. Venkat will be explaining this in detail in the upcoming slide. The next section is about planning security measures. So in case if there are requirements, we have to plan how securely we can deliver that feature. And there will be certain set of security tests which has to be performed, so we have to plan for that. And we there are certain set of security principles, and we have to adhere that in this phase. Like we have to plan for that. One is fail securely. So fail securely principle is that if something goes wrong in the system has to fail in a secure manner. For example, there is a function module which takes the user ID as the input parameter and returns value whether that user is authorized to perform that action or not. So in that case, if something goes wrong within that function module, it should always return telling that that person is not authorized to perform that activity. So it should be always false in this case in the fail securely option. There is also one more principle called fail safe. In that case, it is reverse. For example, you consider a exhibition room where people are inside that room watching something, and if something goes wrong in the door locking mechanism, the door lock should fail safe, so that all the doors should be open and people can come out. So this is called fail safe. And next principle is secure by default. Assume you are delivering something to customer and you are giving him two options. One is secure option, the other one is unsecure option. You should always deliver your product in a secure manner and let the customer change it to unsecure manner if he prefers. So the product should be always secure by default. And never assume trust. If both a system are communicating between each other, we shouldn't always assume trust between both the system. We should get a clarification or a confirmation from both the system that the communication channel between them are secure. And the next principle is least privilege. I can take a leave management system as example. If I as a team member, I will have a privilege only to create a leave, but not to approve or reject any leave request. So that is the least privilege principle. And my manager can see only the leave request created by his team members, and he can act on it, but not on leave request created by any other team members. So this is the least privilege concept. And the next principle is check authorization close to the resource. So this is like from the UI, you will be checking a few authorization, whether the user has permission to access this resource or not, and then based on that you will allow or deny access to that resource. But in the back end you may not be doing that check. So what might happen is, if there is a man in the middle attack possible, then they can change the parameter and they can access the resource which they are not authorized to do so. So in all the cases we should always check the authorization close to the resource. These principles should be incorporated during the security development phase also. So as I mentioned in the training thing, what secure programming is, those things will be implemented in the secure development phase, making sure there are no backdoors or hard-coded user ID or credentials left in the coding. And also in this phase, we will perform a static code scan. A tool will go through all the code possible for path from the code, and it reviews whether there is a vulnerability exist in that code. Also, code review is an effective mechanism to make sure we are not delivering any buggy product. So this is about secure development. And the next phase is security testing. In this phase, we'll be using dash tools, dynamic application security testing tools, or dynamic code scan tools to perform testing. And in this phase we can also invest in external assessment or pen testing activity. And in this phase we will also revisit to the threat modeling report which we have generated in the risk identification phase, and we will make sure whatever action item was identified in the risk identification phase has been developed in the secure development phase. So we'll be checking that. One major difference between dynamic code scan and static code scan is dynamic code scan uh, it will do some changes to the application. It will try to run the application, create something, delete something, and it will try to input some data into the database, and then try to reach out to the all possible corners of the code. That is the positive of dynamic code scan. The next phase is security validation. Once everything is done, an independent party will be performing a validation on the product which will be delivered to the customer. Since they are not related to the development team, they can be impartial, and they can come up with a genuine reports for this. Again, in this phase there can be three types of security validation. One is white box, where the security validation team knows in and out about the application, like which programming language is used, on which version of the server the application is hosted, what is the UI technology used, all those stuff. The black box method is like the validation team doesn't know much about the product. They will be given simply user ID and password for that application, and they will be asked to perform validation on that. And the third type is gray box, where a certain amount of data will be known to the validation team member, but not the full data. So this is about a validation thing. Coming to the last section, it is security response. So you have delivered the product to the customer, and your product is out in the outside world. But then you should also have a response planned. Like in case if a security issue is identified on your product, how it should get reported to you, and how you should try to fix it. This is very important because uh, the- how effective your incident response team, that depends on the brand value of your company. Like if your response team is poor, then definitely it will affect your company's brand value. And if the response team is proactive enough and they are good at what they do, probably they can turn a worst nightmare scenario into a regular normal security issue and avoid a PR embracing situation. So I was part of this team in my previous experience, and trust me, this job is it's very serious. So entire company's brand value and the customer brand value will be dependent on this thing. And we might have to deal with some rogue hackers who are not ready to give some time to the companies to fix the issue. They just want to report the issue, and also they want to publish the issue to the outside world, and that creates a panic in the customer. So assume Fortune 500 companies which are using your product, which they run financial transaction, which they host their trade secret, come to know that there is a 0-day security vulnerability in the application tool, and the vendor has not provided a fix. How shocking it will be to the customer, and they will have a second opinion to think whether they have to use this product or not. So to avoid those kind of situation, having a very good security response team is also very, very important. So these are all the sections of secure SDL, and uh, this should be used by all the software companies. When I say this is the secure SDL, this is not a hard and fast rule that every company will have the same sections or segments. It can be modified according to their requirements. So this is about secure SDL. Moving on to the next topic here, OWASP Juice Shop. So what is OWASP Juice Shop? So OWASP stands for Open Web Application Security Product. It's a NGO or a consortium of companies where they come up with standards for web application security. So they have come up with a vulnerable web application where we can learn or test our security skills using that application. So that application is Juice Shop, and every 5 years or 4 years, they come up with a top 10 vulnerabilities. So this Juice Shop application has these top 10 vulnerabilities apart from other vulnerabilities as well. So it will be a hands-on tool for security researchers to learn more about these security vulnerabilities. So let me try to open this app and try to explain the functionality of this app so that it will be helpful for us to do a threat modeling on this. Let me open this. Just give me a minute. Okay. So this is the Juice Shop app. I hope you can see my screen. Okay. So let me create an account here. So this has a login page for already registered customer. So let me create a new customer and I will give some dummy mail ID. So let me pick one security question. Let me register here. Okay. So let me try to log in. Okay. So this is the juice shop application. So what you can see is you can see all the products and you can add to basket here. So you can also search here for the product inside this juice shop app. Okay, so let me add this product to basket here. Okay, so if I go to my basket, so I can see the product here. I can change the quantity here. I can increase or I can decrease, and I can do a checkout here. So before checking out, let me go back to my account and see my order history. So if you can see what I have ordered in my previous shopping thing, even that is visible. So just for the sake of it, let me check out this thing. Okay, so let me add address here. Okay. So I will select this address and I will continue here. So it provides with a type of delivery which I need. So let me choose a standard delivery and continue. So again, they have payment options here. Like I can add a new card, or I can use a wallet, or I can use a payment or other payment options as well. So let me add a card here. Okay, so there is a validation exist for this. Okay, okay, so okay, so let me submit this. Okay, so I will select this option and will continue with this, and I will place the order here. So my order has been placed here. So if you can see, I can print the confirmation, order confirmation here as a PDF. So this is the order confirmation PDF, and also I can tweet it. Okay, so if I go back to the orders and the order history, I can see the order history here. And apart from this, it also has this my saved address, my payment option, and digital wallet as well. So these are all the functionality of OS Juice Shop. So one thing you have to notice is you have to think like an hacker and find out, okay, this application is providing this feature, where all it can go wrong, or how a hacker can find a bug in this functionality and try to break this application. So this is the purpose of the hands-on event in this workshop. So So we had the demo of this Juice Shop app. So moving further, these are all the features which I showed to you. So login, in the login, we will have a new registration, and I can log in using email ID, password, and I can also use a Google account to log in into this application. We have a search feature available, and in my account option I have user profile, my order, recycling box, my addresses, payment cards, wallet, and privacy and security stuff. And also I have your basket, a checkout, and we can also contact customer for the feedback, like complaint or support chat. And it has a about us photo wall and deluxe membership option in the company tab. So these are all the features of Juice Shop app. So with this, I have concluded my part, and I would be handing over to Venkat. So Venkat will be starting with the introduction to threat modeling stuff, and later we all will be doing a threat modeling on this Juice Shop app, and we'll be sharing the result. Over to you, Venkat.
Chandan, can you just unshare your screen so that I can start sharing my screen?
Sure, done.
Yeah. Just let me know once you are able to see my screen. Just let me know once you are able to see my screen.
Uh, it's loading, Venkat. Yeah, I can see it.
Okay. So, so to start with, as you have actually went through the secure software development lifecycle is covering all aspects of the software development lifecycle. If you would remember the main aspect of the secure software development lifecycle, the first stage preparation is covering two parts: the education as well as the risk assessment. And the main part which you have to note down is that the risk assessment is coming up as part of the preparation phase and not as part of the other stages of the software development life cycle. The reason being, if we see, we would be assessing the risk before we do anything, and that's also the thought process with which the risk assessment is actually brought at the earlier stages of the process. A risk assessment is actually required because that's the thing with which you would be able to assess and understand where are we standing about the application. And with that thought process, the threat modeling is introduced. It is a risk-based approach. It is focusing on identifying and communicating and understanding the kind of security risks we are having. It is giving a process to process to protect something which is of value for you, and the entire process is surrounding that something of value for us. So as part of the process, what we will be doing is we define what is that something of value for us, and then we do the threat modeling to make sure that that thing is actually protected. As we were discussing several times, the motto what we need to note down is threat modeling, performing it at the earlier stages is the best thing. The sooner we do the threat modeling, the better it is. But it is never late. That means we can also do the threat modeling at the later point of time, but doing it at the earlier stages is going to give you better results. As Chandan has mentioned, identifying an issue at the earlier stages and addressing it is much cheaper when compared to identifying an issue once it reached customer and then addressing it. The ideal time for doing the threat modeling is right at the time once you have completed the design phase of your functionality of software development. Before you start development, you go through the design to see which are the places where you can have a potential security issue. There is when there is no plan, when there is no definition which is existing, there is no meaning in doing the threat modeling, because you are just predicting without actually having any concrete thing. So that is the reason you have to have at least the design with you, so that you can go through it to actually understand what are the things and where the possible security, where possibly the security can go wrong. So what is the threat modeling? The threat modeling contains the following aspects. The first one is, as I've told, we need to have at least the design. And design is the, in general, the source based on which we would be trying to assess the threats. Along with the design, most of the times what would be there is the set of assumptions. that I am actually using this component and that component is provided by the third party, I assume it is secure. These are the things which are called as the assumptions. The other part of it is you already know you using a vulnerable component can cause you some kind of issues, but you don't have an option because your functionality requires it. So these are the things which you are already having the list of threats. The other part of it is the set of actions which needs to be taken. The last part is in terms of validating the assumptions and the threats to actually assess whether the things which you are looking at is right and are actually a threat or not. So these are the things which you need to have. Why do we need to do the threat modeling? Threat modeling is required uh, to make sure that you have a secure design with you. That is the building of a design in a secure way. And what it is also is going to contribute is in terms of efficient investment plan. When you have to actually understand where you need to invest, whether there is a serious security issue, if it is, you need to prioritize, and so your investment needs to actually ensure that the serious security issues first addressed without causing a bigger damage to your functionality and your software. It also brings the security and development together. That's the main part. Most of the times security is actually considered as last mile activity which can lead to issues at the later point of time. Threat modeling, using it as part of your secure software development lifecycle, brings in security also as part of your thought process. That is why it is called as secure software development lifecycle. And so it is, the security is part of your development lifecycle. That is the thing which threat modeling is helping you in. What it is going to help you is in identifying the threats and also any potential compliance issues. The threat modeling, when you are actually performing, is also going to cover or consider the aspects of compliance, so that you can say, like, means whether my software is requiring these compliance activities. If yes, how am I actually fulfilling? The next part is in terms of the building the controls, because whenever there is a software which is being in place, you need to also have the required software controls in place to ensure that the security is taken care. The next part is in terms of balancing the risks, controls, and usability. So this is the place where, and if we go back to the example which Chandan is taking, if you are attempting 3 times the invalid login, the software is going to lock you out. So in this case, the risk is if some user is actually forgot their password, they have attempted it 3 times, they will be locked out. So is it actually sufficient that the business continuity is impacted because we are locking the user? What if somebody is just keep on attempting invalid password on the usernames they know, because of which they are blocking several people to be connecting to the system? These are all the things where the actual thought process comes in, whether we actually balancing the risk which is there because of the security, the controls what we are putting to handle it, and whether it is still making the product usable so that I can run my business. Because at the end of the day, we need to be able to run our business, and that business needs to be run in a secure way so that we are able to perform the tasks and continue earning the profits. The other part is in terms of acceptable risks. What are the risks which are acceptable to the organization, maybe because of any reason? As Chandan was also mentioning, there are different ways of actually handling the things. One of the thing is that the risk is acceptable because I can't actually invest, or the risk is too small. Either cases, there are situations where the management intervention is required to accept the risks. What it is also going to bring in is documenting the threats, mitigations, and the accepted risks. All these aspects are already documented. So when it comes to a situation where you have encountered a security issue, you would be able to understand whether it is because of the known things which we have accepted as a risk, or an unknown thing which was not discussed and is because of the new threat landscape evolution. The other part is in terms of it is going to ensure that you can protect your business goals, and also handling the scenarios of some malicious actor is doing something, or somebody is trying to do something accidentally which is leading to a security issue. Just click on a button, it is approved a purchase order of several millions, which is not supposed to be done by somebody. If we were able to understand this, assess this as part of the threat modeling, we would be able to put the required control in place. For example, by telling that any approval which is beyond certain limit have to mandatorily go through an approval flow instead of just being acted on a click of a button. These are the kind of things which can be identified as part of the risk assessment. Identifying the security test cases, this is the place where we would be knowing what are the places where we need to do the specifics of security testing, and also what are the things which needs to go into my security related development processes so that it is securing the things. When we talk about the threat modeling, there are set of people who need to be participating in it, who need to participate in it. The first one is somebody who is actually conducting the threat modeling, the threat modeling expert, the one who is actually going to sit along with the team which is building the scenario, start asking the questions to understand and do the risk assessment. The ideal recommendation in this scenario is that the one who is doing the threat modeling leading, the expert, is somebody from outside the team. The reason for this is if we are sitting together talking about our own built software, it always looks beautiful and cool to us. We will not be able to bring in some external thought into picture which can actually lead to identification of the actual issues. That's the reason the general recommendation when we do a threat modeling is the one who is executing the threat modeling as an expert is somebody from outside, so that they can ask the question, are you sure, is it really that this is the case in your functionality? What if I am tweaking this into this way, and then what would be the problem? Would that be working in the same way as you are expected or not? What if I am entering a number in place of a character in an input field? All these kind of things, if somebody coming from outside is asking the question, it is still acceptable. We would be able to understand and then do the things. The next one is an architect. Architect is the one which is required to be part of the threat modeling because they are the brain behind the functionality, and they should be able to tell why we have designed it and what we have designed. The security expert is the one who is actually going to bring in the security angle as part of the threat modeling, so that they would be able to tell whether how we have actually planned the security, and then how do we actually ensure the security. The component owner is the one who need to actually take the result of threat modeling to make sure that they are acting upon it to make the software more secure. The key developers who are actually part of the development process, so that they can bring in a bit more deeper view whenever there is required. The participants, the recommendation is that the participants are restricted to the more essential or more deeply involved people of the scenario, rather than it's like a public forum, because uh, the threat modeling's target is to assess the risks, to identify the security risks, and that's the place where the main purpose would be solved if we are able to focus always on understanding the security, rather than diverting to discuss some additional some topics which we don't want to actually have as part of security assessment. Threat modeling, when we talk about there are different variants in threat modeling. In general, the threat modeling is actually considered at two bigger levels. One is the complete product, where the end-to-end business process is actually considered. We would see which all components are involved and what is the process flow, and see which all places we need to do a more deeper dive. In general, the result of a product level or the complete product threat modeling is it would be giving you the set of scenarios where you need a deeper look. Uh, when we know the set of scenarios, that's the place where we talk about the process or scenario oriented threat modeling. This is the place where we would be taking a specific business process or functionality or a DevOps scenario, and then we start deep dive into it, how this particular process is implemented, which all places do we have security issues, which all places we have made the assumptions which can lead to the security issues. These are the two major variants. And as Chandan was mentioning, the secure software development life cycle is repetitive, as well the threat modeling is also. In that way, once we have done the threat modeling, it doesn't mean that we never need to do it again. As the threat landscape can evolve quite regularly, the threat modeling also need to revisit to see whether our assessment of our complete product or a specific scenario about the security issues, is it still valid? Are there new security issues or security threats because of which my scenarios or my product is not rendering not secure? That's the reason we in general would be calling it as delta threat modeling. We would look into what is changed, what is the delta. Is it in terms of the product scenario or functionality or architecture changed? Is it the threat landscape evaluation which is changed, because of which we need to do a reassessment of security? When the threat modeling needs to be done, when we need to do the threat modeling, that's the place where, when you are introducing a functionality for the first time, this is the time when you need to already perform a threat modeling to understand where are we standing in terms of our design, and then start implementing the functionality. But as I've just described, we needed to revisit it at a regular intervals. For example, when the system architecture is undergoing a change, or when we are introducing a new process or a flow into it, or when the structure of the existing thing is being changed, these are the places where we need to review to see if our assumptions or our assessment of security is still holding true or not. If not, we need to go for a re-threat modeling so that we can understand where are we standing in terms of security. Apart from this, if you remember the secure software development lifecycle, there is a part called a security response. That's the place where, when there is a security incident occur, how are we actually responding to that particular scenario? The first part is to put the fire off. So we need to actually handle the security issue first to actually see that the security issue is handled. Uh, Whenever such thing happens, it is always recommended you go review your security threat modeling to see whether there are some things which we have missed out, because of which we have to go through the security issue. Is it because of some threat landscape change? Is it because of some missed functionality or an assumption which we have made, or is it because of something else? Recommendation is that in general, it is recommended you review your threat modeling on a regular basis, because the threat landscape is going to be continuously evolving, as well as there are some changes which would be going into your software. So the threat modeling needs to be revisited on a regular basis. The main aspect is in the secure software development lifecycle. What we are expected to do is, as the life cycle is a cycle, we also have the threat modeling going through in that cycle, so that we can actually make sure that whatever we are building in the process is always considering the security as part of it. What do we do? There are five main questions. What are we building? This is the place where the design comes into picture. What is what is of value for us? This is the place where we need to identify what is the thing which we need to protect. What can go wrong is the place where we would start actually thinking into different scenarios which can impact the security of it. What are we going to do about it is the thing where we define the action plan to ensure that the things which can go wrong are already handled. Do we do a good enough job is the thing where we would be reviewing and re-executing the processes again and again to make sure till the time we reach the secure functionality. What are we building? When we talk about it, we have to start with the definition of your scope of the threat modeling. Here what we do is we take the design and then we start understanding the design. At the same time, we would be also defining the scope and the boundary conditions. The next part is like means what you need to actually understand is what do you need to protect. Other part of it is this is the thing where we need to actually start with the architecture diagram, the data flow, what is happening, and what are the kind of data classifications. The data classification is more critical, because if you talk about the things, the data is the thing which can be actually is the main asset. The more critical data we are losing, the bigger impact it would be for us. uh, and the main aspect also is that the uh, people from different roles with the sufficient technical and risk awareness needs to be participating to agree what we are discussing is the set of risks, and then how do we take it forward. The next part of the thing is what can go wrong. This is the place where we do the research to actually understand what are the different things which can go wrong. There are different kind of mechanisms to actually do this. For example, Microsoft Stride, or the threat chains, or the killer chains. These are different ways to actually do the brainstorming to actually understand what can be going wrong with my functionality and software. What are we doing? This is the place where when such a things are identified, how do we actually plan? What is our action plan? The next part is do we do good enough? This is the place where we would have to go back and check the quality, feasibility processes, and the planning to make sure that what we are doing is good enough to make the thing secure. How do we actually do it? The technical setup is the threat modeling. It involves the main thing with the four questions. What are we working on? What can go wrong, and what will we do to find it? So these are the things which we have just discussed. So how do we actually do the threat modeling? By sitting and then start discussing about these questions. That's the main thing which is involved as part of our brainstorming process. Once we do this entire brainstorming process, what would happen is a result which is called as a threat modeling report. That report actually talks about who has participated in it, what are the topics which we have considered, what are the assumptions, boundary conditions which we have made, and then the main aspects of what are we building, what is of value, what can go wrong, what are we doing about it, and what is good, whether it is good enough. These are the things which would be bringing in the actual set of things which we have discussed, and the risks which we have identified. uh, After that, what are the next steps which we want to do, and who owns it? Each step, who is going to own it? It starts with the product owner, and then like means how the person would be executing the next steps. What are the next steps which would be requiring? For example, we listed down the set of assumptions. We need to validate whether the assumptions are still valid or not, whether they are secure or not. Verification of the findings. If as part of the brainstorming we consider that there is a potential issue, we need to verify whether that potential issue is actually an issue or not. uh, if there are issues, what we need to do is we need to take them as part of backlogs. Accepting and documenting the risks. This is the place where we would be writing that these are the set of risks which are identified as part of the threat modeling, and then how are the things which we would be taking up next. And that's the place where how do we actually take the next steps for the accepted risks. For example, what Chandan was also mentioning, do we do the insurance to make sure that when the risk occur, it is actually handled by covering from the third party as part of the risk transfer. That's the set of things. The next part is in terms of how do we actually do it. If you remember, Chandan was taking us through the juice shop, right? So what I have come up here is with the architecture diagram of juice shop. If you see, there are certain aspects which we have here. There are different boxes of functionality which is available here. There is a channel and there is a communication. In this way, if you see, there are three main boundaries of functionality or boxes of functionality we have. There is communication between them, and also there are entry points to each of this functionality. If we see, there is a database which is existing where we would be storing the juice shop orders, the profile created, the information related to the payment methods, all these aspects. The authentication is handled. All these aspects are there. And if we see, this is the place where the actual step of handling the threat modeling comes into picture. As the design is complete, we are with our architecture diagram. The design is explained here. We would be getting into identifying the blocks of functionality. Uh, this is the place where also the aspects of assets, the data which we have about the customer's payment processes is our asset. This is the thing which is of value to us. The actual information of the order which was placed by the customers is an asset that is of value for us. This is the thing which we would be doing. Yeah, and also the other part of it is, if you see, the other part of it is like means what are all the different blocks and the communication between them. There are channels which are actually inbound and outbound to each of these blocks, which are actually having a scope of entry and exit processes. And these are all the places where we have to actually understand and ask the questions. So, do we have the overview of this architecture diagram now? Are we all able to reach and understand the different components involved in the process of the juice shop? When we actually go back to the threat modeling list, if you see, this is the place where we have the boundary conditions, we have the assumptions, and also we have the actual functionality here, which is talking about the different channels of communication, the what is the value for us, actual data what we have persisted or what we would be storing. uh, these are the things which we need to do as part of the first step before we actually get into the brainstorming, discussing about the actual security issues and the risks which can actually occur in the functionality. So the next step what we have to do as part of the threat modeling is to start doing the question, start going through the brainstorming process. As I mentioned, there are different ways to follow. For example, the Microsoft Stride are the killer chains and all those things. So that's the place where what we would be getting is with the list of categories of assessment which we need to do. And each category we would be coming up with set of questions so that the actual threat modeling can be done. Here is the place where the threat modeling leads role come into picture. They would start asking the set of questions, and then the teams needs to start explaining the scenario based on the functionality and architecture, and then start understanding what is actually going, what can actually go wrong. Can we quickly go through this scenario now to identify what are the kind of issues which we can have as part of the juice shop? I take the set of features which Chandan has described, the login mechanism, the search, my accounts, and also the feedback, the company, and then we have the list of questions. Shall we actually just start going through these questions to see what all places we can go wrong with the functionality? What are the places where we can actually have issue with our juice shop now? Maybe the first part what we talk about is first part is about is the access check in place in at all times and all scenarios. When we see the scenario here, is the access check performed always so that what you are doing is what you are supposed to do and nothing more and nothing less than that? if you see each one of these questions, what we have here is access check in place for all at all times and scenarios. Is it possible to mimic a human execution? These are all actually the famous threat patterns which can actually be there in any application, which needs to be actually considered and checked to ensure that a scenario is actually secure or not. And that's the place where threat modeling lead would be coming up with these kind of questions to actually start generating the brainstorming. And then once the brainstorming is started, that's the place where these questions are asked to come up with the list of potential issues what can happen with our application. In this case our threat modeling means juice shop scenario. Is the authentication is there a place where I can just skip the authenticating of the user without logging in? Can I actually start accessing the data or the processes? Can I execute it without actually authenticating myself? If yes, I can cause a lot of issues. Is it possible I can actually access the DB and then wherever the DB access is happening, can I inject SQL so that I can get more data out of it than what I'm supposed to get? Is the input validation happening at all places? For example, when we are searching, is it possible that I can put a script, instead of a simple search term, is it going to execute the script which can actually lead to some kind of a security issue? Also, as Chandan was mentioning, is the things secured by default? How is it actually going to ensure when there is an issue encountered? How is it going to do the things in as part of the processes? And also whether the appropriate access checks are done and at the access controls are in place, so that a person who is actually performing a functionality is able to cross beyond it and then do something more than what they were supposed to do. So these are different set of questions which are actually asked, which the threat modeling lead would be asking, and this is the place where the actual brainstorming with the team would be coming into picture. And this is the place where our architect would be sitting along with us. They would be explaining what is the architecture. The security expert would be bringing in the security angle into it, and this is the place where we would be also describing what can go wrong with it. And as we have actually taken an example of juice shop, which is by default defined and designed to uh, be vulnerable, it is also having a lot of issues on these all these aspects. As I was describing, once we go through the threat modeling, the next step is actually to come up with the threat modeling report, and that's the place where we would be getting the set of issues for each of these questions which we ask as a threat modeling lead. And if you see, for each of these questions, what is mainly coming up is in terms of the places where the actual issues are there, and this is what is expected to be coming up as part of the function threat modeling workshop, when we are going through the architecture, reviewing it, seeing that these are all the places where we can have potential issues, and this is the thing which is going to go into the threat modeling report, which would bring in the next step of things which we need to act upon. So, okay. So then when we go through this, if you see, the process of threat modeling is actually targeted to ask the directed questions towards the security, to with a thought process of bringing in the potential security risks which can be there as part of the functionality what we are building, which would give us a process to actually plan handling these issues as part of the next steps, and then implement them to lead to a secure functionality implementation. This is the thing which is main target of the secure software development lifecycle process, especially with the threat modeling part, which is the phase where you're supposed to identify the risks and then include it as part of your planning phase in terms of the development activities, backlogs, additional testing functionality, verification, so that your application is secure. So the main aspect what we need to consider as part of a conclusion is security must be considered from the beginning of SDLC. This is the main thing what we were discussing throughout the session. The earlier you are able to identify a security issue, the better it would be for you, the cheaper it would be for you. The later you identify it is going to be more complex and also causing more bigger damage. The earlier security issue is identified, it is going to be easy for you to address it. Risk-based approach in secure SDL will increase the possibility of identifying the security issues at the earliest. That would give you also the scope and possibility to plan to ensure that there are no security issues. Threat modeling is the thing which is bringing in the approach to identify, communicate, and understand the weakness as part of your security processes. Threat modeling will provide you the list of aspects which needs to be focused on security. Performing threat modeling regularly would help you in is required so that you can cope with the changes in the threat landscape. Any questions?
We do have a couple of questions. Before we get into the questions, someone has requested if you could spend a little more time on the Juice Shop broken session authentication section.
Mhm. Yes, Aditya, colleagues, the main aspect what we are actually trying to cover here is in terms of what is the process to do the risk assessment aspect. So that is the place where what we are actually focusing is in terms of identifying the different potential risks what can occur as part of the process. How to actually handle it is the thing which needs to be actually taken up as part of the development life cycle, the next steps. And that is the reason we were focusing more in terms of how to think to find the potential issues what are happening here. And that is also the reason we are not going into each type of risk, how to handle it, and then implementation. That is actually going to be coming as part of the next steps of the software development life cycle.
Okay, so the next question is how does extreme programming fit inside SDLC? So, and what does it mean by extreme programming? Basically, write code now and ship the product and fix the bugs later.
The main aspect of the secure software development lifecycle is actually in terms of identifying the issues which can potentially happen before you start developing. That's the reason when you actually do the secure software development lifecycle, before writing the code, as I have also started or we have started describing, you would try to identify all the possible security issues what can happen as part of your risk assessment. Your development processes are expected and would be actually focusing on building the software in a secure way. So irrespective of whether you are using extreme programming or the other way, if you are following the secure software development lifecycle including the threat modeling processes, you were already having the potential list of security issues what can happen, and so your programming is expected to cover those aspects to ensure that your functionality is secure. And in that way, the actual development processes, irrespective of the methodology of implementing the code, if you follow secure software development lifecycle, is expected to take care of understanding the risks and include them as part of your development processes which are already considering, and you are implementing the functionality in a secure way.
Okay, thank you for that, Venkat. Thank you so much, Chandan. I think we are at the end of our question and answer session. Chandan, do you have something to add? Chandan, we're not able to hear you.
Yep. Chandan is yes. So Chandan has typed his statement in the chat. So what he's mentioning is extreme programming is part of secure coding. So that is the reason. That's the way actually. Irrespective means you are already taking care of security as part of the coding, even during the extreme programming. That's what he is actually trying to say.
Okay, great. I think we're done with the questions as well. I'm going to hand it back to Sumi. So Sumi has, I think Sumi would like to thank you and has a couple of prepared statements. So I'm going to hand it back to Sumi. On behalf of Rocheston, thank you so much for coming and giving us this very in-depth and detailed workshop about extreme programming and secure software development life cycles, and showing us the OWASP Juice app application and how it works. So over to you, Sumi.
Thank you, Aditya. Thank you, Mr. Chandan and Venkateswara. That was amazing. It was like smooth, and 2 hours was very informative. We have come to the end of the session and a fabulous 5 day conference, which went on very, very well with the teamwork and all that. So I would like to introduce myself. I'm Sumi from Rocheston, which I said in the very beginning. So there is a small thank you note that I would like to share. It has been our pleasure to host the participants at Rocheston Reinvent Penetration Testing Conference 2021. The participants were absolutely enthusiastic. Without their support, this would not have been possible. We from Rocheston sincerely thank all the participants who attended this reInvent conference. We have been fortunate to have some of the eminent persons from academy and industry who participated as speakers and workshop hosts in this conference. We thank them from their sincere efforts in putting together mind-boggling presentations and highly enriching workshops. We wish to thank Mr. Haja Mohideen, our President and CTO, who envisioned the conference, and our organizing team, which had made this conference a reality. We are very much thankful to all the sponsors and training institute partners of this conference. Without their support, it would not have been possible to organize this conference. Thank you everyone for making this happen. Hoping to see you all again in few months in another conference that will be hosted by Rocheston. Thank you. Thank you so much for being a very good audience, and I'm happy to signing off for now. See you soon. Good night.
Thank you.
Thank you. Good night.